Hello, so this is the second part of the video. So again, we're in chapter 4.4 and we're going to be looking at solving logarithmic equations. Okay. So let's look at logarithmic equation. Here we have a log base b of m equals c. This is a logarithmic. We know we can rewrite it as exponential, as b to the c equals m. So this is your base, here's the exponent, and here's what it equals. Okay? So we know how to go back and forth between exponential and log. And that's the main thing, how we're going to be solving these. If you have a logarithmic equation, in general, you're going to rewrite it as an exponential and then solve. The one thing you have to look out for here is when you get a solution, you need to check it. Because log log 4 to say -1, this is not defined. Okay? Log is not defined for numbers less than 0. Now, don't confuse this with saying that if you get an answer it's less than 0 that it's not defined. It's just if your answer makes the log less than 0, it's not defined. Because if we have log of 4 to the x plus 10, if we solve this and got, equals some number over here, okay? If we solve this and we got x equals -9 as our answer, -9 will still work because when you plug -9 into this, you'll get log 4 -9 plus 10. -9 plus 10 is 1. All right? And we know that log is defined for 1. So just because we got negative answer doesn't mean it's not defined. Now, if we got -11, it wouldn't be defined because -11 plus 10 is a -1, and -1's not defined. Okay? Okay. So we need to check our work when we're done. So let's look at examples, how you solve this. Do the most basic one first. So we have log 2, x minus 4 equals 3. Now what we're going to do is we're going to rewrite this as a log, or as an exponential. It's written as a log, rewrite it as an exponential. So here's our base, here's our power. So we have 2 to the third equals x minus 4. Now 2 to the third is 8. 8 equals x minus 4. Add 4 to both sides, and we get 12. X equals 12. Now we need to check to make sure 12 doesn't make the logs equal to a negative number on the inside, and they don't. 12 minus 4 is 8, so we know that log 2 of 8 is 3, so we know it works out. Okay, let's look at another example. Okay, rewrite this. Well, ln is base e. Okay. What we're going to first want to do before we rewrite this, we're going to have to get rid of the 4 that's in front of the log. And there's really two ways of doing this. We could pull the 4 on the inside like this, and then you get ln 3x to the 4th power equals 8. All right? And that would work. That'd be one way of doing it. But then you're ending up with the 4th power, and then it's complicated. It might be easier, instead of doing that, the second way of solving this, and you will get the same answer either way. Second way is to divide both sides by 4. If we do that, the 4 dividing both sides of the equation by 4, here they cancel. 8 divided by 4 is 2. Give ln of 3x equals 2, which is much simpler than this up here. So that would be the preferred way when doing these problems. Then what we do is to get rid of the natural log, we have to raise both sides to the power of e. Okay. Here, the property of logs, those cancel. We have 3x equals e to the second. Then divide both sides by 3. And at that point, you'd have to plug it into a calculator to figure it out. But we do know that e to the second plus 3 is positive. And if we look up here, 3 is positive. So we know it'll work out because you'll have a positive answer that you're putting into here. Okay, which is where you have to worry because you don't want that, what I shaded yellow, to be negative. Okay. And we could check it anyway. If you plug e to the 3 in there, what you end up with is 4 ln 3 e to the second over 3, all right? Well, here the 3's cancel. You end up with 4 ln e to the second. Then we're going to pull the 2 down. Get 4 times 2 equals ln e. All right? Pull it down. And then the ln and the e cancel, and you get 8. 4 times 2 is 8, which is what we had originally. Okay, let's look at another harder example. Log x plus log x minus 3 equals 1. Okay. Now, the problem with this is in order to really write this, we need one logarithm. Right here we kind of have two terms essentially. But we can use our rules, the product rule here. So we're going to use the product rule, and we're going to use it backwards, right? The product rule states any log m times n translates as log m plus log n. So we are going to go this direction. We have this right here. We're going to go the other way. So we're going to take log x plus log x minus 3 and go backwards using the product rule. And we're going to rewrite this as log base 10 of x times x minus 3 equals 1. Okay? At which point we know, since we have one log, we can undo the log by raising both sides to the power of 10, or rewriting it as an exponential is what we're doing. Not raising both sides to the power of 10. We're writing the base as power of 10. Okay? Here, those cancel. You have x minus 3 equals 10 to the first. So we rewrote it as an exponential. You get x squared minus 3x equals 10. Subtract 10 from both sides. Factor it. Get x minus 5 times x plus 2 equals 0. Then set each of them equal to 0 and solve, and you'll get x equals 5 and x equals negative 2. Now, could go ahead and check. In the original one, did either 5 or negative 2 make either of the logs negative? And the thing is negative 2 will make both these logs negative, both here and here. So we can throw out negative 2. So negative 2 fails. It's outside the domain here. So this one's gone. And we have x equals 5 as our solution. Now the negative 2 didn't have to necessarily fail. It could have passed. Both could have passed. Both could have failed. But in this case, we had one pass and one fail. Let's do another example. Of ln x minus 3 equals ln 7x minus 23 minus ln x plus 1. Okay? Now, again, on this one, we have the problem is we have addition and subtraction of terms here in the log. We need to get rid of that. So we're going to use the quotient rule. Quotient rule states that log m over n equals log m minus log n. We're going to again go backwards on this rule. Okay, so the problem here is this subtraction right here. We'll go backwards, use the product rule here to rewrite the right-hand side. Left-hand side doesn't change. Okay, have that. Each side has one natural log in this case. We could cancel them if we want, or cancel them like this. Okay, here they cancel. You end up with x minus 3 equals 7x minus 23 over x plus 1. Now, before I continue, we're going to note that we can't have x equals negative 1. And the reason for that is we're dividing. So if our answer has x equals negative 1, that's not allowed. Besides which, negative 1 would make this term over here be problematic, and this term. So it would make all three terms. But you always have to remember you can't divide by 0. Okay, so then what we're going to do is to solve this, we're going to multiply both sides by x plus 1. So you have x minus 3, x plus 1 equals 7x minus 23. The reason for that is we multiply both sides by x plus 1. Here they cancel. Okay, and we end up with the equation we have below. Now we're going to FOIL out the x minus 3 times x plus 1. We FOIL that. We're going to go x times x, x squared. X times 1 is 1x. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. Right-hand side doesn't change. Combine like terms on the left-hand side, here and here. Get x squared minus 2x minus 3 equals 7x minus 23. Now we're going to move everything to the left-hand side. We know we're going to have to factor this. So I do that by subtracting 7x from both sides, adding 23 to both sides. Here, you're going to get 0 on the right-hand side. On the left-hand side, you're going to get x squared minus 9x plus 20 equals 0. Now, are there two factors of 20 that add to 9? The answer is yes, 5 and 4. But since we're adding a negative 9, they're both going to be negative. So you have x minus 5 times x minus 4 equals 0. You can FOIL this out and see it works. Then we set each of the factors equal to 0 and solve, and you get x equals 5 and x equals 4 as solutions. Now we have to make sure that neither one of these solutions make any of the logs, any of the natural logs, negative. If we look up here at the original one, neither one of them make any of the natural log terms. It doesn't make this, this, or that, any of those equal to 0 or less than 0. Could equal, or less than or equal to 0. So we're good. We know it works, so these are your solutions. Okay, so that's the solving logarithmic. Let's look at some word problems. Okay, so we're going to move on to some word problems for this chapter. Okay, so first example here, it's going to be from the textbook, is we have a medical research company. They're saying that the chance of you having an accident, the risk factor, increases as a percentage of your blood and your alcohol in your blood. Okay, and they have this equation for it. They say, here's the equation. R is your risk factor equals 6 to the E 12.77 times X, where X is the percentage of alcohol in your blood and risk is the risk factor. So let's say you have a 17% chance of getting into an accident or risk factor, and this is these typically in a year is how they look at these. They don't look at you a single day. It's like in a year, if you, it's throughout a year. So they're saying, let's look at 17, and this is all, so your risk factor is 17 equals 6e 12.77x, okay? Now, so that's the problem set up. What we're going to do is we need to divide both sides by 6 to get rid of that. So then we have 17 divided by 6 equals e to the 12.77x. Now to get rid of e, we're going to take ln of both sides. Okay, and the ln will cancel with the e. All right, if we take ln of both sides, here they cancel. Then we just divide both sides by 12.77. So this is a number. Just think of this as a number. In fact, you can plug it in your calculator and get the number. And then you're going to divide that number by 12.77. So we're going to take ln 17 of 6 divided by 12.77 equals x. When you work this out, this is going to equal 0.08. So what it says is that you have a 17% chance getting into an accident in a year if your blood alcohol content is 0.08. Another example, last example from this chapter. We're going to go back to the height equation that we talked about in the previous chapters. And we have this measurement of height, percentage of height. And it's a function equals this equation here. All right. And in this problem, though, they're going to say, at what age are you 85% of your adult height? So they're wanting to know when this is 85. I know typically in problems, typically you're going to do percent as a decimal, but for some reason these are all set up so that it's not a decimal. You just have to look at it carefully when deciding, okay, these problems. So plug 85 into f of x equals 29 plus 48.8 log of x plus 1. Well, first thing is we need to get rid of the 29 because we have addition here. So we're going to subtract 29 from both sides. That'll give you 56. Okay, then we're going to divide both sides by 48.8. Okay, here they cancel. This again is a number. So we have 56, 48.8 equals log x plus 1. I know I'm going to rewrite this log as an exponential. So this is 10 to this number, 56 over 48.8. This is a number. Equals x plus 1. So we wrote it as an exponential. I'm going to subtract 1 from both sides and I'll get my answer. Okay, subtracted 1 from both sides. Now, at this point, you'd have to plug it into a calculator, get your answer. But when you do, you get 13, approximately. So at age of 13, a boy will have achieved 85% of his height, is what this says. Okay, that is it for this chapter. Did it in 2 parts. Hope you enjoyed it. If you need any help, just give me a holler on email, preferably. Talk to you later.